Hi everyone, welcome to this video on finding the gradient from coordinates. So we've discussed how to find the gradient being that it's vertical over horizontal, but sometimes we want to be able to find the gradient from a pair of coordinates and not necessarily have to look at a picture. So we're going to look at an example first of all that's going to take us through how to do that when we've got both. So we've got coordinates here, and then we've also got a diagram here with our Cartesian coordinates and so on, so that we could work out our vertical and horizontal. So we're going to use that to help us, alright? So if we look, we've got a horizontal distance of 1 unit, okay, from the point 1 to 2, and then up 2 units here. Alright, so we could say, we already know that by vertical over horizontal, the gradient is going to be 2. Alright, so we know that already, but we're really interested in how we can actually figure that out from the coordinates. So we've been given the coordinates of A and the coordinates of B. Okay, so A is 1, 2, so we can see there 1 across, 2 up, and then B is 2, 4, so 2 across and 4 up, and we've got to calculate its gradient. So we're going to do this time by using a formula that allows us to do it from the actual coordinates themselves instead of having to draw out all of this and measure how many across and how many up we're going. Okay, so the formula itself, it looks like this. So we've got M for gradient is equal to y2, take away y1, so the difference in the y coordinates divided by the difference in the x coordinates. So if we look at what that actually means in the context of this question, it's easier to see with the picture. So if we look at the x coordinates, which is the first one, if we've got the difference in the x's, the difference between 2 and 1 is 1, right? So that's the horizontal distance. The vertical distance is the difference between the y coordinates. So we've got 4 and 2 for our y coordinates. So the difference between the y coordinates is 2. So that gives us our vertical distance. So this is really just another way of writing down vertical over horizontal. Okay? But it's using coordinates instead. So this is how we actually go about doing a question. So first thing I'd recommend you do is actually write down the coordinates next to your formula, okay? And what that's going to mean is you can label these up, because this is quite confusing, all these 2's and 1's and y's and x's being the same and stuff. So this is how we're going to set it up, alright? So remember, x coordinates go first, and our y coordinates go second. And all the little number for here is to differentiate between the first set of coordinates and the second set, okay? So this is like point 1 and point 2. It is not squared, okay? The little 2 is at the bottom, so it is not squared. It is just a number that lets us know that this is the second point and this is the first point. There's no mathematical nature about the 1 and 2 at all. Alright, so all we've got to do now is we substitute into a formula. So we have y2 is 4. There we go, y2 is the first one. Then we take away y1, which is 2. Then we divide that by x2 is 2 and x1 is 1. So you can see there, all I've done is, because I've labelled these already, x1, y1, x2, y2, I can just go back to here and go y2 is 4, y1 is 2 and so on, and substitute them in without making any mistakes, okay? So from here I'm just doing a couple of little sums. So 4 take away 2 is 2, 2 take away 1 is 1. Now, when you get to this stage, it's really important that you are able to simplify this, okay, into something that's a little bit more easy to work with. So 2 over 1, as we all know, is just 2. So we have m is equal to 2, and it's the gradient of the point AB. So we're going to subscript that there, AB. And that's our answer, okay? So what we discussed at the beginning is that we know that the vertical is 2 and horizontal is 1, so we know that the gradient is going to be 2, but this method here lets us do it using a simple example just from the coordinates. So technically, I don't actually even need to know what the diagram looks like. I can just do that from the coordinates themselves, alright? So just given a pair of coordinates now, what I can do is I can work out the gradient of the line between those two coordinates, alright? So that's the first example. That's a really, really simple one. I'm going to take another pair of points now. So make sure you get that all copied down, okay? You can pause me if you want to remember, rewind, look at it again. I'm going to do a more difficult example now, with another pair of coordinates, alright? So, this time, so we're going to calculate the gradient of the line P minus 3, 5, Q 2, 4. Okay, so calculate the gradient of the line P minus 3, 5, Q 2, 4. So we've been given a pair of coordinates, no diagram. Okay, no diagram at all, and we have to work out the gradient from that. So, how do we go about that then? We start off with our formula. So m is y2, take away y1, all over x2, take away x1, and I'm going to write out my coordinates. I'm really, really keen that you do this. This stops any kind of silly mistakes happening, like putting numbers in the wrong place and so on. So make sure that you do this every time. Alright, so that's us good to go. So, from here, all we do is we say y2 is 4, y1 is 5, x2 is 2, and x1 is negative 3. Now I'm taking away negative 3, okay? So you just got to be really careful with the signs, especially when you've got negative coordinates. As soon as you see negative coordinates, you really need to think, I need to be careful with signs on the bottom. Okay? So, again, a couple of little sums. So we've got 4 take away 5 is negative 1. And then 2 take away negative 3 gives us 5. There's nothing we can do with that, we can't simplify that. So m pq is equal to negative 1/5. And that there is our final answer. So that one was a little more complicated because we ended up with not only a negative gradient but one that was a fraction as well. Okay, so you should be able to do this one confidently that the answer came out to 2, so example 1, and then also make sure you get this one copied out as well. The only thing that's changed is that the points have become a little bit more difficult to deal with in terms of the sum at this line here. But if you just do 4 take away 5, get the answer, 2 take away minus 3, get the answer, and then simplify from there if you can, then you'll have cracked it. Alright? Okay, so that's how to find gradient using a pair of coordinates.